Hi everyone, I hope you're all doing well. I had some information or some recommendations from office hours that you guys would like to see some more videos a little bit step by step, so I thought that I would help you out here. So I'm just going to start with a simple region. It's between x squared, x equals 2, x equals 8, and the x-axis. So what we're going to focus on is actually revolving this region around the x-axis. So this is that same thing that I have highlighted yellow, and I'm going to actually revolve it. So it gives me this like solid. So there's no space in here. It's completely solid. So our goal is to actually calculate the volume of that solid. So one of the things that's important to realize is since there is no space, so a little preview, since that there is no space, there's going to be just one kind of like disk that we talk about. So there's our axis of rotation. We're at the x-axis. And since we're touching that entire region against the x-axis, axis of rotation, this is called the disk method. Some people do it with a C, some people with a K. I pick C to be different. So we technically have like these little circles that we're rotating around. So when we wanted to find the area of a circle, you guys know that's pi r squared. But what's happening is we are actually adding up a bunch of circles or a bunch of disks. So what we do that is we end up doing pi, you can put it inside or outside the integral, r squared, and this is going to be dx because we have a horizontal axis of rotation. So for this one, let's actually figure out what that radius is. So our little radius here is that distance from x squared down to the x-axis. So just like how we were doing area between curves and we did like top minus bottom, this is still top minus bottom for that radius. For us, the top is x squared. For us, the bottom is 0, so we don't really have to write it. So when we set this up all in the integral, we're going to have pi inside or outside, I don't care, x squared squared dx. They tell us from 2 to 8, so we're going to go from 2 to 8. What's different though is what if we revolve around something that is not the x-axis? So for instance, what if we go around the line y equals -10? So here's my nice little drawing. I'll give you guys a sketch pad of it. So we're going to revolve this guy, same region, but now you kind of notice there's this big fat hole in the middle, and we before could only find the solid. So we need to somehow subtract that hole. That's where the washer method comes in. So let me just scroll down a second. Come on, computer. Okay. So we're going around y equals -10 now. I like to draw that little arrow so I remember. And then if we go this whole route around, we have this kind of a disk. So we're starting off there. But then, let's go green, we have this other little piece that we have to actually subtract out. So what I like to think about is there is actually an outer radius, so the one furthest away from the x-axis, from the axis of rotation, my bad, is r out. And the one closest to the axis of rotation is our r in. So when we do this in general, when we have washers, I like to kind of think of it as the whole volume minus the whole, spelling. And we need an r out. That's our outer radius, furthest from the axis of rotation. So for us, that would be x squared minus that -10. So we still have this top minus bottom when we'd find that little distance between the x squared and the -10. But for this one, it ends up being x squared plus 10. Our r our inner radius, is actually going to be the distance from the x-axis, so that's at y equals 0, down to -10, which is just 10. When we do the washers, we again need a larger volume, so we're taking this whole volume of the region minus this little like circle part that we're subtracting out. So the entire region minus this circle. So the entire region first is going to be that R out. So I'll put the pi outside or inside, I don't care. It'll be pi R out squared for us dx minus pi R in squared for us dx. You can sometimes see this as two integrals. I like to remind myself that I'm subtracting two separate things, or as a single integral. I prefer to, totally up to you. I'll take it either way, but let's do it for this one. So again, we still have pi integral something squared dx minus pi integral something squared dx. What we're going to put in are actually our R in and R out. Having trouble picking colors. Okay, so there's our R out. That'll get the entire volume. But now we have to subtract out that whole. So that's our R in. That's going to be 10. Same region as before, so my bounds are still 2 to 8 and 2 to 8. This is one that you see most often. But sometimes the axis that you rotate around is actually above your region. So this was below, we're going to go above. So let me set that up for a second, I'll be right back. Hey there, back again. So here's our region, same thing as before, but now our horizontal axis of rotation, they call it revolution, is actually up at 100. So if I revolve this, you'll notice that it's still some sort of solid originally, but then there's this giant hole that we're taking out. So it's gonna have to be washer again. And you'll see that if you look at these little discs right here, depending on where you are in the region, this hole that's in the middle is actually gonna change. So we have to take that into account just by figuring out what the equation is. Let's go back. So here we are at 100. And so I'm going to kind of just put this a little bit lower than I normally would have. So y equals 100. When we rotate this around, there is again a larger portion. And then if we rotate this around, there's this like hole. Please excuse my bad drawing. So we still have this R in and R out. Let me do that in green. So from the axis of rotation to the furthest part of the region, that's our R out. So for us, our R out is actually 100 minus 0. That's our x-axis. So this is just 100. For us, the R in this time is the piece that is closest. So here's R in, here's R out. Oh, I already wrote that, cool. So this piece that's kind of closest. So for us, that inner radius, the top part is actually 100 minus our equation here, which is x squared. So the whole thing will be a part of R out. The little hole, H-O-L-E, that we need to subtract out is using the R in. So this is washer again. We have a hole, have to subtract it out. So pi 100 squared dx from 2 to 8, that's the whole entire thing, minus 100 minus x squared dx. So we have the whole region minus the little hole that we actually need to take out. So thanks. Please let me know as questions come up. I'm going to have office hours every day and I'll post more information day to day. Thanks everyone.